and pleasure to be here. Let me start off by doing a quick introduction of my panelists. I'll start off with Shane. Shane is the CEO of Kongsberg Digital, which is the industrial software arm of the Kongsberg Group, which is a Norwegian technology leader with over 200 years of heritage. Shane doesn't look so old, but he's a PhD in chemical engineering and has over 20 years of experience in digital and industrial information. Let me move on to Dr. Raj Gattupalli. He's the president and CEO of Honeywell UOP. He's a, he's a PhD in chemical engineering, brings in deep experience in process development and commercialization, and helps customers improve efficiency, reliability, and emissions performance. And last but not the least, I've got Mr. Amit Sharma, who's the managing director and CEO of Tata Consulting Engineers. Amit is again, a mechanical engineer with global academic exposure, brings about 30 plus years of experience across energy, infrastructure, transportation, and industrial sectors. I hope I've done justice to all of you gentlemen for your introductions, but if there is something that I've missed out, please feel free to add. Let me start off by an introduction for myself. My name is Neville Dumasia. I'm a partner with Ernst & Young in India, and I look after the industrials and energy business. Privileged to be here at the IEW forum, and it's an exciting place to be, something that I keep coming every year. And I always am impressed with the amount of ideas, the amount of thoughts, the amount of innovation that keeps coming up in all these panels and discussions, and very happy to see what's actually happening around the world. I thought I'd make a few comments before I get into the Q&A with my panelists. So let me start off. I mean, clearly this energy transition is not just going to succeed because we have intent, because we're keen to do it. It really requires a hell of a lot of capital. Capital is the place where we really start off with, because unless and until you actually invest a large amount of money in the industries which are hard to abate, it's not going to be possible for this to actually come into fruition. So it's a very, very important aspect over here. And as of the last couple of years from IEA, what we've got is $2.2 to $2.4 trillion has been invested in this clean energy. But the estimate is that you will probably need closer to 4 trillion year on year from 2030. So that's a significant amount of money. When you come closer home to India, what you see is a huge number of transactions that have happened in the recent past, about 1,400 odd. 1,400 transactions in the green energy space, investing about $33 billion of capital into the country. 70% of that has come from the private equity space, 70%. Now, unfortunately, there's a positive and there's a negative as well. When there is private equity money that comes in, typically what they look for is making sure that they're investing in reputable business houses, easy cash flows, visibility. But several of these places that we're really trying to do now are areas which are kind of uncharted, right? There'll be huge number of new technologies that people are experimenting with, making them move from pilot to scale. So those are some of the challenges that hard-to-abate sectors actually come through. And I think it's important. It's an important area that we'll focus on and we'll drill upon a little bit more. In addition, this whole thing around digital and digital tools, how do you actually get a good sense? How do you get a good estimate of what's actually happening? Can you visualize a project or projects before they're actually launched to see whether there is certainty of cash flow, certainty of proof of concept, etc. And that's where I think we'll touch upon with Shane to get some more insights for us. This matters. The reason why I thought I'd start off and give you this context is matters because design choices made today can generate emissions for close to 30 or 40 years. You'll do an investment, plan comes up in 3, 4, 5 years, but the repercussions or the benefits of this will accrue to you for the next 30 or 40 odd years. Manufacturing processes and technology decides whether cleaner products can be made at scale, and digital systems decide whether improvements can actually last. So with that brief introduction and context setting, I'm going to jump into some of the questions. I've tried to divide it into 3 themes. The first theme being investment policy and incentives. Do they actually change decision making? And I'm going to start off perhaps with the furthest. Amit, may I pull you in first? So as heavy industry, Amit, moves towards complex multi-technology decarbonization pathways, how can companies ensure that large-scale capital deployment remains economically viable while delivering measurable emission reductions?
Thanks, Neville. Good afternoon, everyone. I think this is an important question. You can get a lot of money, but you're not starting on fresh slate. You have an existing asset, and you're looking at expansion. And in India, particularly, when the energy mix is getting diverse, and you're also adding a lot of energy, adding a lot of production capacities, that's what India is doing, unlike the West, where the energy is stabilized a bit. And so you're doing change, but we are adding stuff both in metals and hydrocarbons and the whole general energy generation. How do you utilize this money and capital that comes in? I think that's where desire needs to really map with real IRRs. And a couple of years back, when green was really strong and decarb was being initially debated, we championed the cause of circularity as a key part of the mix. And it's not that it's a low hanging fruit, but it's something that gives you a boost to get your maths right in your investments. So, circularity, which for example is aluminum recycling, steel iron recycling, is definitely one part. Second is how do you look at brownfield and your greenfield investments? You can't, for example, steel cannot go to hydrogen DRI straight away, right? You need a mix of gas-based DRI, electric arc furnaces, while your blast furnaces continue. Then how do you make your blast furnaces relevant for the green era? Well, you do carbon capture, and then you convert that to methanol or SAF, and you try to do these adjacencies of circularity, both in terms of molecule circularity, but also more electrification, electrons into your mix, whether it's a refinery or steel. When it comes to aluminum, copper, they've already experiencing a big growth because of the whole AI and the EV story. And hence, green electricity helps a lot. And last but not the least, when you look at electricity, how do you balance, uh, you know, convenient, intermittent, renewable grid with the base load? Because if you don't marry these two, you will not get a resilient grid for industrial use. And I think these are the equations to solve that will give you the right return of investment with the starting case, more focus on circularity before you do the big bets. That's what we've seen in the market emerging and panning out as boards approve various options. That's what I say, Neville.
Thank you. Thank you, Amit. Raj, may I bring you in on the second question? It's uh, in most of the hard-to-abate sectors, refining, fuels and chemicals, cleaner alternatives still cost more than the conventional ones. It's just a lot more expensive to do infuse clean as opposed to convention. Do you, from your vantage point of a global CEO, do you see today's government incentives enough to scale cleaner fuels, or are we still limited to small scale trials, pilots? And maybe you could give us a view across the world if possible, and then India.
Yeah, no, great question, Neville. I think this is important for us to tackle. So I'm going to go back a little bit on how at Honeywell UOP we did the things here. So way back when we invented our own technology to convert heifer-based feedstock to renewable fuels. In those days, renewable diesel was very famous. This is back 20 years, and nobody was trying to adopt the technology because the cost of production was higher at that time. And then if you look at in today's point of view, there are many heifer-based feedstock going to renewable diesel or SAF, sustainable aviation fuel, that have been operating. And the reason for that is because the economics are right for that particular technology. And the newer technologies that we have today, whether it's methanol to sustainable aviation fuel or carbon capture or ethanol, any other technologies that we have today are pretty new, that we have, that technology providers have launched in the last 4 or 5 years. So it takes an evolution to reduce the cost of production. So do you really need incentives to be able to start up? Absolutely. When we first started the heifer-based feedstock, we had government incentives, whether it's in the US or other parts of the world, that triggered investments. And once the triggered investments happen, the technology developments will overtake itself, and then you get to a point where it is cost of production is going to go down, and then you're going to make much more profitable. I think that's exactly where today's new technologies are right now. When you have to do a seed investment, whether it's private investors or government incentives, that helps seed the investment. And once the investment happens, I think you will see a good return on investments. I'll give an example. Even as us as a technology provider, we've been looking at all the options in converting to make renewable fuels. One example that I have here is when we look at whether it's one of the biggest things that we have challenged on renewable fuels is feedstock. Heifer-based feedstocks has been very famous because, as I said, the cost of production has been low enough that people are making money from it. But then there is not enough feedstock that is available in that space. So people are moving towards other alternatives, but the economics are not really making sense unless an incentive that kicks in. So this is where we are trying to develop technologies. For example, a technology that we just launched recently called biocrude upgrading, where you can actually utilize, for a country like India, where energy security is important and a lot of biomass that is available, how could you use that biomass to convert into renewable fuels? So we've developed a technology where biomass, abundant biomass, which is cheap, you could take that to biocrude and then upgrade the biocrude to make marine fuel or SAF to make the economics better. So it has to be a part of technology provider licensor innovation to reduce the cost, but also to seed the investment, to kickstart the investment, we might need a little bit of government incentives at the start. So it's a combination of both. It's going to be help, but long term, no one will make an investment assuming that the incentives are going to be there forever.
Right.
And that's not the investment strategy, a good investment strategy in a view. So it has to work on its own.
And at least in India, what we are seeing, Raj, is in the biomass space, we find that the supply chain is becoming quite a bit of a challenge.
Right.
Are you seeing that in other parts of the world as well?
Absolutely, right. So because you have to have a place where you can aggregate all of the stuff, or if you can't aggregate all of the stuff, you can have a hub and spoke model where you make the biocrude in different spots and bring the biocrude to a common spot where you upgrade it together. So you'll have to think about it that way. Otherwise, constructing a world scale facility in one area might be extremely challenging just because of the logistics of how you are to do the transportation. So in this particular space, I think a hub and spoke model is something that is that might be worth to look at.
Thank you.
Yep.
Shane, question for you. Today's investors don't just ask what a technology does, they ask whether it is going to be able to perform reliability for the next 20, 30 odd years. How are digital tools helping build this confidence amongst the owner promoters? What kind of insights do these digital tools actually provide them when they're making a capital decision, making sure that this is really something which is viable, fundable? What kind of visibility do they actually get to see?
We were briefly touching on this in the back room as we were preparing, and I think we've talked about this. There's two tracks. You have your brownfield assets, which accounts for the majority of the hard-to-abate industry today, and of course we're going to add capacity through greenfields and new projects. So you kind of have to look at this in two ways. If you look at the brownfield assets that exist today, digitalization is really, efficiency 2.0. Right, it's about standardizing, about eliminating costs, taking out the emissions that we have in the existing infrastructure, and there's a certain capacity there to do that. Digitalization's really doing that. There's a lot of examples of this happening. Everything from cement factories, taking down 2 or 3% from these kilns. You see the steel manufacturing, also taking out maybe 5-6% efficiency, and efficiency is cost. It's emissions, and it's capacity throughput that we're adding there. And then if you look at carbon capture, which I'm a big believer in, we're going to have a mix of technologies, mix of electrons and molecules. Some will be able to take completely down to electrification, green electrification, and some we're not. So we need CCS to be able to capture a lot of this and take it out. But the chemicals, the solvents that we use there to capture the CO2, and then the high steam that's required to release it, there's been fantastic headway made on taking out 20% of the energy costs. And it's almost 1-to-1 to emissions. It's about 20-ish% of emissions as well, just on that process in of itself. So again, through digitalization, and a lot of people throw around AI as a term, but it's old school machine learning and just better ways of working through digital tools. So on the brownfield, efficiency 2.0, think about that. And that can fund quite a bit of the energy transition as well. Then when you're looking at the greenfields, and I say this again and again, if we're planning, building, executing, designing, engineering these assets the way we've done it for 20, 30, 40 years, we've failed. we've absolutely failed because we're not taking advantage of the digital tools that we have. That is the way of working, the future way of working, these plants of the future, etc. So we're getting in very much into the EPC stage, into the engineering stage. Make sure you're using engineering tools to design more optimally, because a lot of people think of emissions on the OPEX side, but 1 ton of steel on a subsea infrastructure, if you think CCUS, is 2 tons of CO2. So if you can optimize more at the limit using digital tools, you already have made a significant input into taking down the CO2 footprint of those assets. We're working with one particular LNG facility in Canada, and their big cost base was on the OPEX side was flying people in and out. It's a very remote area. They needed to prove that they could take down the CO2 footprint there. So they rewired the whole facility around a digital twin, a different way of working. We had to use AI inside there, and this is a mixture of the generative and more machine learning, and then just basic tools, better ways of working there. And that had to take down 10% on the CO2 footprint and 50% on the OPEX cost. So again, it goes hand in hand. But the willingness to change the mindset of how they were going to operate that plant. And the way we build these facilities is you normally take people or experts who have done this before and you go, hey, you built an LNG facility, 10 of them around the world, let's come in. It doesn't require that way of thinking. You need someone who's maybe never built an LNG facility and go, why would you do it that way? And blending these experts with kind of new ways of thinking, that is just what will really, really take down. And then I know we talked about electrification. Today, these hard-to-abate industries contribute about 40% of all global emissions. Right. That's a lot. By direct electrification, you can take down 25% of those emissions. So getting that involved from day one, from a design thinking perspective, and then maybe you have to look at locations and what type of molecules you're putting behind there, that can have a significant impact. But when you start integrating like this, it becomes more complex for humans to be able to operate it. That's where digital plays its a key role.
Fantastic. And sorry, this is a question that I find hard to resist, but in all digital models and digital tools, the one thing that is a perennial problem is data. Oh, yeah. The underlying data. Yeah, yeah. It's almost as if you're saying, oh, tell me about it.
No, but I say, everyone goes, hey, we'll start digital when we get our data problem sorted out. And I said, look, that's never going to happen, right? Let's be real. Let's be pragmatic about it. And we operate and maintain our assets with the level of data we have. They're not blowing up all over the world. So we have data to operate these facilities. But taking that data, we often say that's the minimum amount of data in a structure to operate these plants. And then anything you can do to improve it, taking it into a digital platform, it could be a data platform, a knowledge graph, whatever it is, you already opened up new efficiency gains, right? So yes, data is the perennial problem, but I think people get caught up in it. Oh, my data will be perfect next year. It'll never be perfect. So starting now is something we keep advising people, and then iteratively improve on it. Yeah.
Fantastic. Thank you. Thank you very much. Let me go to the next set of questions. And Raj, let me pull you in first, and then Amit, and then Shane. Raj, in sectors again like refining, fuels, chemicals, aviation, clean power alone is not going to be enough to reach net zero. It's a pipe dream to say that's the case. What combination of technologies are you seeing? Biorefinery, CCU, efficiency movements. What kind of things are you seeing around the world, which you could share with the audience today?
Yeah, no, that's a good question, but also that question we can go on for an hour.
You've got 20 minutes, 40 seconds now.
Yeah, but let me give a little bit of perspective in that, right? So if you, as you said, electricity power, clean power alone is not going to do it, just because there are large sectors of industry where electrification is not going to work. Even for cars, which we all thought is going to work great, think about electrification did really well, but then now we are at a point where internal combustion engines have become very more popular in the last couple of years. So it all starts with like, if you think about the main things that we are looking at, whether it's renewable diesel actually has become very popular in many parts of the world, and that's how we started with. That's sustainable energy era started with a lot of renewable diesel, and that we have established a lot of good technologies. But the place that we are struggling in that right now is availability of feedstock, as I said, and the more different types of feedstocks that we can work on, rather than just relying on used cooking oil or the heifer-based feedstock, extending that feedstocks to whether it's biomass, whether it's methanol, whether it's ethanol, and then making it much more energy efficient and reducing the cost of production is where the name of the game is right now in that space. And then the second one is carbon capture, as you said. Carbon capture, there is a lot of announcements of projects. I think I was talking to one of the journalists this morning, like, okay, there are a lot of announcements of projects in India, even in carbon capture, but we haven't seen a lot of investments happening in that space. And why? Carbon capture is, in my view, easy. CO2 capture technology has been there forever, for a long time. But what are you going to do with that CO2? Right? You don't really have the infrastructure to do sequestration in India. So what are you going to do with that? So CO2 monetization, CO2 valorization is something that everybody is focused on. But there are only few things that you can do. CO2 to methanol, and then you take the methanol and then you make SAF. That chain is where the technologies have been really well progressing right now. And I think there are a lot of investments people are looking at in that space, and there's a lot of talk about it. Even at IEW last year, this year, there's a lot of discussion about it. I think you're going to see a lot of investments in that space. As I said, once you start the seed investment and then some investments happen, I definitely see a lot of improvements in that space in terms of cost of production decreases. But I think that is where that industry is going. Pretty much carbon capture and then taking that to methanol and then methanol to SAF, or stopping with SAF and using that as a marine fuel or something like that. And then hydrogen. Hydrogen is one area I'm a little disappointed in that space, because even though green hydrogen has been talked about for a long time, there's a good, actually India is maybe the pioneers in that space. A lot of good work has happened in India on the hydrogen. The rest of the world, a lot of dabbling with electrolyzers and other stuff at a smaller scale, but large investments are happening in India on the green hydrogen space. Good amount of work on the blue hydrogen space in the rest of the world, which I think is in a good shape there. Ultimately, those investments will more happen if they can find an alternative to that, as I said, monetization of CO2. The captured CO2, if they can actually, whether if they make ammonia or methanol, what are you going to do with it? Are you going to get an offtake at a premium or not for that, for the investment that you're putting in? So a lot of investments happening in a lot of different places. But more importantly, electrification is also, to me, is the name of the game with existing infrastructure. Yeah. If you have a refinery, if you have a petrochemical industry or cement and power industry, replacing those reboilers, replacing those heat exchangers with simple electric heaters or electric equipment has given a lot of, decarbonization. I think people undermine that and go big sometimes, but small things can add up. Fantastic. And that's something that we have seen in the industry, especially I think India is adopting that a little bit, and I've seen that in public sectors where we are working closely with a few of them in electrifying their existing refinery process units. So that's been a good uptick.
Lovely. So, and Amit, when you at Tata Consulting Engineers are looking at serving your clients, do you see a significant shift in terms of companies trying to use more green energy, electrification, or are they trying to see a combination of the newer renewable energy sources? What's your take on it from your vantage point?
Yeah, so, last 5 years, we did a lot of feasibility studies, the initial, FEL 1, FEL 2s. And first, as I said, to start your business case or embark on this journey of energy transition, most of our customers looked at circularity, because we kind of gave them the maths behind circularity is something that'll give you a business case that's viable. So we've crossed that first hurdle. Most of the recycling plants in steel or recycling in aluminum, copper, that's happening. We're doing global projects, both in Europe, US, as well as India, Middle East. The second part is, and I want to touch these three themes. The first theme is, if you go to renewable sources, how do you marry electronics and flywheels? And that's resilience. And let me explain this. When we looked at traditional power base load, it had a flywheel in it, and sudden demands of high amperage, the grid was stable. When you go to solar, wind, which is a grid following rather than grid forming, these networks and grids can't handle that load that the industry requires. And so there is a struggle between how do you balance flywheels and power electronics, because you can't have a virtual flywheel take such high loads that, say, a refinery, reformers, electrolyzers, or induction motors require. So that's the first theme. How do you marry virtual flywheels with physical flywheels to get the stability when you get into a mix of renewables and baseload, irrespective of any industry? You want to shift your furnaces to electric fired furnaces, but you've got motors, the load out there is varying, and so that gets the complexity. So that's number one, and we're trying to figure that out, marrying the power electronics and the turbines and generators and flywheels together. The second thing is the CapEx and OpEx marriage. As I said, there isn't a greenfield strategy. Most of the strategies are a combination of brownfield and greenfield. And unless you truly connect CapEx and OpEx mindset inside your company, you won't get the total cost of ownership that's as planned, because you'll get into new challenges as you embark on this journey. You will look at value adjacencies, you look at energy balance equations, you look at product mix, input output changes, and the market will change suddenly. We'll have either commercial challenges or technology roadmap challenges. So you got to be nimble and agile. And to do that, the second theme is, how do you marry the CapEx and OpEx? Simple example, how do you get the projects team and the operation teams to be completely aligned for a very nimble and agile assets as you are in the energy transition? And that's wherein the digital story starts in with digital twins. It's no longer a nice to have story, it's a must have if you are balancing your energy transition story with both electrifications and the physical flywheel that you anyway need. And the third theme is the advent of AI. Of course, AI is an opportunity with all the story we are hearing on data centers and the surrounding value chain, but both stability of your energy with multiple sources, the CapEx, OpEx bridge with the digital twins, is how do you leverage your know-how to rapidly innovate and align with the sudden demand changes in the market, including technology leaps or complete changes. And AI no longer is based on just 3 years back, we were looking at prognostics based on all data to have LLMs be taught first. I think the way AI is leapfrogging, actually we are seeing weeks and months tangible outcomes coming with the data that resides in the four walls of the enterprise. So if you have traditional processes, if you have both OpEx, CapEx, and processes that you did in your industry, and you leverage AI, you're innovating faster. We're working with 2-3 customers in the hard-to-abate sector, cement being one, steel and aluminum, and the focus on rewiring the energy product with their in-house know-how, knowledge bank, and their process licenses with AI tools is phenomenal. I think these 3 themes will determine how the energy transition, the energy stability, and multiple sources of energy will balance and coexist. And last but not the least, as I said, unlike some of the other economies, India is going to quadruple its energy requirement for 8,000 terawatt hours to almost 27,000 terawatt hours. It's going to triple its steel from 120 million tons per annum to 300 million tons per annum. We're going from 500 gigawatts of power to 1,000 gigawatts of power per year by 2030. So amidst this transition, you have to keep on addition also. So all forms of energy, all forms of circularity, and a complete CapEx, OpEx integration is a must for this journey to succeed.
Thank you, Amit. And Shane, when you work with clients, just for them to evaluate the impact or the financial feasibility of different types of feedstock, different technologies, does the digital twin or technologies at Kongsberg, are you able to provide a clear view to companies saying this path is much more profitable, shorter turnaround time, return on investment is faster? Is this an area that you're working at Kongsberg using AI, using advanced language learning?
Oh, absolutely. Yeah, I think every tech company has to start stepping into that, or otherwise they can't call themselves a tech company in my mind. But it's back to, there's always different parts of the life cycle of any given asset. There's the design part where we offer a lot of services there, and that's a mix, because as an industry, we're still very risk averse. It's a highly critical, safety critical industry. And I use this word purposely, unleashing black box AI into that's not the right way to go about things, right? There's still, when you think about these large language models, where were they trained? They scraped the internet for information. A lot of the information on how we operate and maintain our assets, it wasn't put on the internet. Right. It lives in-house. So what we go back to the drawing board and say, simulation is having this revival, and it's not just specifically from Kongsberg, but these physics-based models. And I really liked what Jensen Huang said last year, where the next wave of AI, industrial AI, is about understanding the physical world. And this is where that hybrid mix of inertia, momentum, all of this stuff you can simulate using physics is becoming really important. That happens in the design phase. So that blend we do offer with our own tools, but we also offer it through third parties. And I think that is very key for having gray box or explainable AI and how we actually design and build our processes. When it comes to return of investment, we hear a lot about that. You can kind of spin this a little bit different, return on value. On the operations side, it's happening. You see this in multiple areas, like in cement, as we mentioned already, taking out 2 to 3% on these smart kilns. On steel, just understanding the core temperature of these rollers. You've been able to take about 4 or 5% energy efficiency out of there, and this is something where I see happening in pockets, but not really being shared. And that's one of the core principles of digital. It's about being open, about sharing this. And I feel that's a little bit lacking. Mm-hmm. It's kind of a collective hurdle we have to overcome. Yeah. This isn't a problem just for India or Europe. It's a world problem. So more and more these what people consider a competitive advantage should be shared inside organizations. And that's what digital is really good at.
That's a fantastic segue into the next question. I really wanted to ask the fellow panelists, saying, do you see a lot of cross-sector collaboration? Do you genuinely see fertilizer, oil and gas, cement, etc., sharing good practices, or as Shane pointed out, most of us keeping it hidden, saying competitive advantage for ourselves? Are you seeing, and could you share some examples of what you're seeing for cross-sector collaboration in India, outside India? Would be delighted to hear your views. Raj, Amit.
I can start. I think the cross-sector collaboration has to happen, especially on the digital side. I'll give an example in this space. We, as Honeywell technology licensor, we provide licensing to multiple different technologies, whether it's a refining sector or petrochemical sector or other areas. And connecting those process units that are operating at any different part of the world is important. And the reason for that is, once you connect those units, you get a lot of data, and we talked about how data is important there. But then using that data to help our customers operate the plants much more efficiently, because we are the ones who develop the technology, we are the ones who actually have the inherent process models assigned with it. But now you're not only connecting one process unit, but if you think about entire refinery, that includes not just one asset in terms of one particular refining, but you have petrochemicals, but then you have utilities, but then you have other parts of the network there. Connecting all of that stuff and getting the data and then harmonizing the entire plant is what the name of the game is right now. And within the last 5 years back, when we actually talked to our customers about connecting the units and getting the data and helping them operate efficiently, there was a lot of pushback. Today, I don't really have to do that. Okay. Customers are actually asking us to be able to get this connected and get this data to us so that they can help us. We can help them. And we have seen a lot of improvement in that space. And that's where I think a lot more cross collaboration can happen in making it much better. Within the last 2 years, we have connected about 1,000 process units.
Wow.
By December last year, we did our 1,000th process unit connection. Well, connection is not only connection, getting the data and helping the customers in operating it efficiently. That's where we talk about a lot of decarbonization using new technologies, but decarbonization using AI, because you can operate it much more efficiently, is where I think cross collaboration can help significantly.
Thank you, Rajesh. Amit, anything from your side?
Yeah, I think all the industries that are looking at electrification benefit, and already that synergies we try to do through our own networks, especially when you get to electrification. As I said, how do you marry the base load with the intermittent renewable load? a renewable generation. And so that is definitely required for chemicals, steel, refineries. So that's the electrification and the stable grid strategy. And people are collaborating on that, number one. That's electrons, right? The next is hydrogen. If you want to decarbonize, you have so much of theory on with hydrogen, whether it's steel, whether it's refineries, whether it's chemical, low energy physics. But how do you get the hydrogen at a point that it makes it viable? At $6, $7 a kg, it's not viable. Everybody wants to break the threshold of $1 a kg. I think that's where I would do injustice if I don't talk about the Shanti Bill, where nuclear can be a great strategy world over with the renaissance of nuclear to really get you hydrogen at $1. It provides you steam at high energy, high temperature, but also base load. And to use that, I mean, the best way to produce hydrogen is to crack water because with electrolysis, the percentage efficiencies are very low. But having said that, the small modular reactors and the large reactors and what India is embarking on the 100 gigawatt nuclear mission, which adds to the gas economy, the oil economy, the coal, everything else, right? It's not competing. It's all additive. So everybody's looking at how to leverage nuclear in a strategy with private sector now allowed to operate, especially in India after the Shanti Bill. And the third part of collaboration is, at the end of the day, whether you do electrification or hydrogen, at the end of the day, you got to marry the brownfield and greenfield. And that's where the asset life cycle and smart plant strategies work. So we're finding people experiment. Initially people thought this is an IT project. And then they realized IT cannot do justice to this. This is deep process domain, which is integral to where you work. And so they became a completely engineering-led project. And that's also not true. So it's a Venn diagram. And then we invented the word IT, OT. And I think that's the third part where industry must collaborate. It must not look at this is not invented here syndrome. I am different and they are different. The IT-OT collaboration is a true area where adjacencies, best practices can go and leapfrog cross industry sectors. And if you get the IT-OT right, your electrification and the hydrogen strategies will really yield results on your energy transition and be viable and with tangible outcomes. You don't have to look at subsidies and policies, but you're reinventing your business, rewiring your business. And I think that's where we're trying to facilitate through our own channels of communication and policy levels to get the IT-OT right.
Gentlemen, I would just say thank you very much for your detailed insights, all of you. Really appreciate it. I did notice Cassie walking across. I'm assuming a slipper will come flying our way if you don't evict this stage quickly. But once again, delight, wonderful meeting all of you. Thank you so much, and catch you for the rest of the day.
Thank you.
Very much.